We continue solving systems, but today we have a special type of systems. We have to determine how many solutions it has. So we have to answer the question, what if they don't have only one solution? What could lead to that? Well, remember we graph lines, and it's possible that our lines don't intersect at one point. So let's look at some situations like that. So we have this system, so we're going to go about solving the exact same way we have before. Let's see here, we got a 2, so if I multiply the bottom equation by 2, I'll get 2y and a 2y. So I'm going to rewrite my bottom equation as negative 6x plus 2y equals 14. Now the top one I'm just going to rewrite the exact same way it was. Now I need to subtract them to cancel out my y's. Negative 6x minus a negative or plus 6x is 0. 2y minus 2y is 0. So there's nothing left on that side. Negative 8 minus 14. Negative 22. What happened is my x and y's both canceled out. And I got something that's not true. 0 is not equal to 22. So this type of system here has 0 solutions because the lines never intersect. Or maybe you can think of that as these lines are parallel. They never touch. So we have this situation where we solve our system and we have something that's never true. Right? 0 is never equal to 22. So we know these lines never intersect. So that's one case we could have besides the one solution. Let's look at this example here. I'm going to multiply the top equation by 3 because that'll give me a negative 3x and that'll cancel with the 3x. I'm going to rewrite them over here. So negative 3x plus 6y is equal to negative 6 and 3x, rewriting the bottom equation. Negative 3 plus 3, and I'm going to add them together because the signs are opposite. Negative 3 plus 3 is 0. 6 minus 6 is 0. Is equal to negative 6 plus 6 is 0. Last time we got something that was never true. This is always true. So notice all our variables canceled again in this case. That's always true. So what that means is the system has many or infinite number of solutions because the lines are the same. They're always equal to each other. It's always true. So this top line is always equal to, is always right on top of the bottom line. So that presents us with two additional cases. The previous case where something was never true and the lines are parallel and never intersect. Or the second case where it's always true and there's infinite number or many solutions because the lines are the same. So let's go through and solve some examples and identify the number of solutions that each one has as 0, 1, or infinitely many. So you got a negative 2, so if I multiply the bottom equation by 2, my y's will cancel out. So negative 6x plus 2y is equal to 24. Rewrite the top one. And because the signs are opposite here, I'm going to add them. 6 minus 6 is 0. Negative 2y plus 2y is 0, so I have nothing left. And then 10 plus 24 is 34. All my variables cancel out. This is never true. So that means the number of solutions is 0. There is no solutions. So sometimes we write that as a 0 with a slash through it, or we could write just no solutions. So as an answer, here's your two options, right? A 0 with a dash through it. Don't just write a 0, because 0, that's just the number of solutions. A 0 with a dash through it, or write no solutions. So these lines are parallel. Next example, I'm going to multiply the top one by 2, because then I'll have a negative 2x and a positive 2x. So if I multiply through, negative 2x plus 2y equals 8, and then rewrite the bottom one, just copy it over. So if I add them together, they have opposite signs, so I'm going to add them together. Negative 2 plus 2 is 0. 2y plus y is 3y. 8 plus a negative 11 is negative 3 divided by 3, sorry. So y is equal to negative 1. Now, I gotta find what x is. So if I go back, negative x plus y, but I know y is negative 1, equals 4. So add 1 to both sides. Negative x is equal to 5 divided by negative 1. X is equal to negative 5. So I have an x and a y. So this problem is like one I've done before. So this problem has one solution, and it's negative 5, negative 1. So in this case, the lines intersect one time. See with the next example, if I multiply the top one by 2, because that would give me 10x, and I got a negative 10x. So multiplying everything by 2, I get 10x minus 6y is equal to 12. On the bottom, I get negative 10x, rewriting the bottom one. So opposite signs, so I'm going to add 10x minus 10x is 0. Negative 6y plus 6y is 0. 12 plus a negative 12 is 0. 0 is equal to 0. That's always true. So there are infinitely many solutions. Infinitely many solutions. The lines are the same. So 3 examples, 3 ways to solve, 3 answers you will get. Right? We did a lot of linear combinations. You can solve using substitution or graphing. Remember, with graphing, with the infinitely many solutions, the lines are going to be on top of each other, the same line. With one solution, the lines will have one point of intersection, and with no solutions, the lines will be parallel. I would like you to solve the following 2 on your own and come to class and tell me how many solutions these last 2 problems each have. And don't forget, keep weightlifting.